So now let's look at this theorem, which is called the extreme value theorem, EVT. It says a function f is continuous on a closed interval AB, then it must have both absolute maximum and absolute minimum on this interval AB. So here is some important information. So this function should be a continuous function. The interval should be a closed interval. Then you can guarantee that the absolute maximum and the absolute minimum exist. Okay, so, but how to find it? This theorem just tells you they must exist somewhere, but it does not tell you where are they. Okay, so we need to find a way to locate the absolute maximum and absolute minimum for a continuous function on a closed interval. So before that, let's look at the first graph we have done. So let's look at this graph, right? So this graph, so you can see that the absolute maximum, absolute minimum may happen at the endpoints or the local extrema, right? So for a function, the endpoint is easy. You can just locate the endpoint quickly from the domain, closed interval. But what about the local extrema? Where are the local extremas? So the local extrema would be the candidates for the global extrema, right? So to find a local extrema, so now let's look at look at this observation, local extrema. So where the local extrema happens, it happens at maybe this is the curve, right? At here, and here, at here, right? So at here, the tangent line at this local extrema are zeros. So that means the derivative at these points equals 0. Okay, let's look at another situation. It may be here, right? This is also the local minimum. So at this point, the derivative does not exist. So both cases would be the local extrema. So are you familiar with these two cases? The derivative equals 0. The derivative does not exist. Yes, these are the critical values or critical points. So in other words, if we have the critical points, then the critical points would be the candidates, right? Of course, you should include the endpoints would also be the candidates. And the critical points plus the endpoints would be all the candidates for the global extrema. So you just need to evaluate, give the values, function values at these points, then compare which one is the biggest one and which one is the smallest one. Then you will find the absolute maximum, absolute minimum quickly, right? So this theorem, the next theorem tells you this information. How to find, it also tells you how to find the global max and global minimum for a continuous function on a closed interval. So we assume the function f(x) is continuous on a closed interval AB. Let f of c, the f values at x equals c be the absolute maximum. So sometimes we just say that maximum means the absolute maximum. Or absolute minimum. We just say minimum. On this interval AB. Then C is either a critical value or critical point, or one of the endpoints. A or B, right? So this theorem tells you that the critical values, the endpoints, would be your candidates. We have no other choices. So now we use an example to tell you how to determine the maximum or the minimum values on the closed interval for a continuous function. So now let's look at this example. We have g of t, which is equal to 2t cubed plus 3t squared minus 12t plus 4. On a closed interval, this is -4 to 2. So this is a polynomial function. It's continuous always, right? And the interval is a closed interval. So there is a very standard steps, okay, to find the global maximum and global minimum. Step 1, we need to find critical points. Okay, or find critical values. So how to find it? We have to take the derivative first, right? The derivative would be 6t squared plus 6t minus 12. Okay. Then, since this is a polynomial, right, it exists everywhere, so there's no point on this interval make that does not exist. So we have to set this derivative equals 0. We want to find, so we have another choice, right? From the definition of the critical point, does not exist or make it to be 0. So we set the derivative equals 0. Then you will have 6t squared plus 6t minus 12 equals 0, right? So solve it. Let's solve this quadratic equation, right? Try to factorize it. We divide by 6 first to simplify. T squared plus t minus 2 equals 0. So let's try to factorize. It's plus 2 t minus 1 equals 0. So we have 2 t equals -2 or t equals 1. So let's see if these two are the critical points. So the domain is -4 to 2, right? It's here. This is the domain. So let's say -2 is inside, yes. 1 is inside, yes. So both are the critical values. So the next one, step 2. Step 2 is to compare the values, the f values, or the function values, sorry, function values at the critical points or critical values and the end points. Here is -4 and 2. Then we can get the largest value and the smallest value. The largest one would be the global or the absolute maximum or maximum. The smallest one would be the absolute minimum. So now we can draw a table to compare the values. So the first column is the t values. The second column is the function value g of t here. So we have the candidates is the critical points we have, which is -2, right? -2, 1 here. And the end points is what? -4 and 2. -4 and 2. Then we plug in the numbers, right? G of -2. So let's plug in, do not plug into the derivative, right? We should plug into the original function. So this is the 2 times -2 cube, right? Plus 3 times -2 square minus 12 times -2 plus 4, right? Then you will get a number which is 24. Similarly, g of 1, which is -3. G of -4, which is -28. G of 2 is 8. So compare. So this is the smallest number. So this is the absolute minimum values. And this is the largest number. So this would be the absolute maximum or maximum values. Okay. So this is a very quick example. So now let's look at still the same. G of t equals 2t cubed plus 3t squared minus 12t plus 4. But we change the domain, from 0 to 2. So the same step, we take the derivative, which is equal to 6t squared plus 6t minus 12, right? So since this exists everywhere, so we can set this one to be 0. So that means 6t squared plus 6t minus 12 equals 0. We know how to factorize it, right? It would be t plus 2t minus 1 equals 0. So we have done this in the previous example. So then you have t equals -2, t equals 1. So we have 2, but you should look at the domain, which is from 0 to 2. So that means -2 is not in the domain. So this one is not the critical values. So we only have one critical value. So t equals 1 is the critical value. Okay? Then the second step is still compare the numbers. So g of t, right? So we have 1. The endpoint is 0 and 2. Right? So g of 1, we have to do the calculation, which is -3. And g of 0, you can do the calculation, which is 4. G of 2, g of 0 equals 4. G of 2 equals 8. So compare these three numbers. So this would be the minimum values, the absolute minimum. This would be the maximum value. So this is the absolute max. Right. So for the different domain, you may have the different answers.